Hi, welcome to Space Club, where every month in this series, I, Anastasia, will feature two sessions on the same topic, a live stream interactive conversation with a guest expert, where you will be able to ask questions in the chat while the expert answers them live, and follow-up Zoom meetup, where you will be able to ask questions directly. The main goal of Zoom meetups is to discuss the topic in more details with invited expert. Thank you, American Center in Moscow for this opportunity. Today we will talk about astrobiology, the search for life beyond Earth. Our guest expert is Dr. Graham Lau. He is an astrobiologist, science communicator, holding extensive academic knowledge in biology, chemistry, astrophysics, and geology. And he specializes in examining life influence on its environment and our pursuit of extraterrestrial life forms. Dr. Lau's research has taken him to Canadian high Arctic and multiple global particle accelerators for X-ray spectroscopy studies. As the host of NASA-funded Ask an Astrobiologist livestream, he illuminates the intriguing field of astrobiology for a broad audience. And in his current role, Dr. Lau expertly steers the communication and marketing for Blue Marble Space, a forward-thinking nonprofit. Wow, I'm so happy to have you here, Graham.
Anastasia, thank you so much. It's a pleasure to join you and all of your audience as well.
Thank you. And I guess we will start with the basics. What is astrobiology?
Yeah, astrobiology is part of our very long-standing human quest to better understand the nature of life in the universe. Astrobiology is, from a very basic definition, trying to understand the origins, the evolution, the distribution of life in the universe. But it's also a lot more than that. It's trying to understand why we're here, like who and what we are. It's the question we've been asking ourselves for millennia through different cultural pursuits, through religion and philosophy, and through science to better understand our place in the universe.
So this is not about looking for aliens, right?
It includes that too. So, the search for extraterrestrial life is one facet of astrobiology. Astrobiology puts us out amongst the stars, asking the bigger question of how life on our biosphere on Earth, what that tells us about the possibility for life elsewhere, and what we can learn about looking for life elsewhere.
Great. I know you prepared a small presentation, as an intro, so people will get more information and then they can ask you questions. We can start from that.
Yeah, that'd be great. Yeah, I have some slides and some images I can walk through and just discuss this field of astrobiology.
Great. Yeah. And we already have so many interesting questions and comments.
Awesome. Yeah, so I just threw together some idea of what astrobiology is for those who are interested. I think I, like your audience, everyone tuning in, most likely, as well as many people around our entire planet of our 8 billion plus civilization, have looked at the stars at night and wondered, are we alone? Is there something more? Humans have been doing this for a very long time, asking ourselves very big questions about what this all means and looking out there into the universe. And then for some of us, maybe who are also fans of science fiction, we've seen aliens presented in various ways in video games and novels and movies and television shows and every other way that we can create ideas of what aliens might look like. I mean, we often create aliens that look very much like us or like life on Earth, but we've also tried a few times to envision what alien life might be like if it was really utterly alien and way different.
What is your favorite here?
Oh gosh, I don't know. I mean, I love the Alien franchise in general. So in the top left, that image of the xenomorph from the Alien franchise. I really love the original Alien film by Ridley Scott. I think it did an amazing job of presenting how alien life could be, with the idea of like the face hugger coming out of the egg and then imbuing almost like a virus, like putting its offspring inside the human body and intermixing its DNA with humans to create the xenomorph. I love that idea. I'm a huge fan of Star Trek and Star Wars, but I also play video games, so I love Mass Effect. And there's a lot of really cool things out there. There's also images here from Starship Troopers and Avatar. There's been a lot of really cool attempts in science fiction to show some alien life and what it might be like.
And it never, contradicts with your scientific mind. All those,
Yes and no. I mean, as any scientist will tell you, the more that you learn, the more you have to suspend your disbelief at some storytelling. Because sometimes in movies and television shows, the writers, maybe they don't understand the science, or they take certain liberties with the science to allow them to tell a better story. This happens in a lot of different ways. Like a great example is Interstellar.
Mhm.
Interstellar is a beautiful film, but the very premise of the film is flawed. The premise that Earth is dying and we need to go to another world to terraform it makes no sense. If we have that technology, we would just terraform the Earth, but they needed that as a basis to tell the bigger story they wanted to tell. And so I'm okay with that.
All right. Yeah, let's continue.
Yeah, so like I mentioned, astrobiology is this study of origins, evolution, and distribution of life. Basically, where does life come from? How does life change and interact with the planet over time? And is there life out there? These are big questions. And this field has been around practically through all of human history, but only really known as astrobiology for a little less than a century. In 1941, a philosopher, Lawrence Lafleur, used the term for the first time that we know of in a scientific manner to imply life beyond Earth. In 1953, a Belarusian polymath was the first person to use astrobiology as the name of a book in the USSR. But the field itself is very old and has been changing a lot through time. But a lot of the biggest discoveries that have really forced us to start wondering if we're on the cusp of discovering alien life have come fairly recently. Back in the 1960s, we discovered these extremophiles living in a geothermal pond. So in that top right image, that's a pool in Yellowstone National Park in the U.S. Called Grand Prismatic. It was there that they first discovered Thermus aquaticus, a bacterium that could survive very high temperatures, way beyond what humans thought before that it could survive. In the top left in this image is a picture of a black smoker. Discovered in 1977 for the first time and now explored around the world. These vents on the ocean floor are places where we find oases of life surviving around these vents. And they changed a lot of thinking about where life might start and whether or not life could begin and evolve through oceans primarily.
And extremophiles are the microorganisms that survive in extreme environment, right?
Yes and no. So an extremophile is a term we use for any organism that can survive in an extreme environment. And so most of the time when we're talking about extremophiles, we're talking about microbes. But around hydrothermal vents, there's albino crabs and shrimp. There are long tube worms called Riftia pachyptila that use microbes for part of their digestive system. But we also have extremophiles of various kinds, like wood frogs that live and survive very freezing temperatures in the soil in northern Canada. Many fish are extremophiles. They can survive freezing and rethawing. And in many ways, we humans are extremophiles too, in a certain way. Many of the organisms that thrive on the surface of our planet breathe oxygen. That is rather extreme and didn't exist on our planet for a very long time. It wasn't until about 2.5 to 2.7 billion years ago that there was enough oxygen in the atmosphere to make using oxygen a viable metabolic pathway. And so we are extremophiles compared to the earliest life forms on Earth. And so it's all relative, that word, but it really is a way for us to say, like, what's different from us? What things are living in high temperatures, low temperatures, with a lot of salt, a lot of pressure? How are things different in different places around the world? And how does that let us better understand what might be out there? And we can speak more about extremophiles if people have questions about the different kinds of extremophiles we find. There's a lot of really cool stuff we've discovered all around the world, from the depths of the ocean to hot springs and hydrothermal systems and all kinds of things like that.
I think the best one is tardigrade. Yeah.
On the lower left, it kind of looks like a tardigrade. So that image in the lower left is actually a picture from a meteorite, the Allen Hills meteorite, ALH 84001. It was the first meteorite detected in the Allen Hills region of Antarctica in 1984. It had been on the ice for some tens of thousands of years, had traveled through space for a very long time, and was launched off the surface of Mars many billions of years ago through an impact. This is a very famous meteorite. In 1996, some researchers from NASA proposed that they had found signs of possible Martian alien life inside of this meteorite. And so that image that looks kind of like a worm in the lower left is an image that they first showed in this paper in Science in 1996. Now that is actually much, much smaller than known microbes. That thing is only a few nanometers, really. It's very, very small. But since that time, a lot of other scientists have explored the data from that paper, and now we can say pretty conclusively that we don't have any signs of life in that rock. But it was a very intriguing paper. In 1996, it was this paper that caused NASA to rename their exobiology branch astrobiology. And so that's when the term astrobiology really entered the parlance for the language we're using to describe it. Before 1996, if you saw like science fiction shows and things like that, like Star Trek: The Next Generation, you might have heard like xenobiology was used a lot, or exobiology was used to describe the same thing. And now we use the term astrobiology more than not.
So what is the difference, astro and exobiology?
Yeah, I mean, they all kind of mean the same thing. Xenobiology, exploring the biology of something alien. Exobiology, exploring the biology of something out there. Astrobiology, exploring biology in the context of the cosmos. They all basically mean the same kinds of ideas, though. Understanding what life is and whether or not we're alone.
And do you think what will be the future next term?
Yeah, I don't know how the science will change. I will say, scientifically, one of the best and worst things we've ever done to science happened, in the Renaissance and then into the Enlightenment. We had science broken apart. And so it used to be that anyone who was exploring, chemistry and physics in these different realms was a natural philosopher. We had polymaths and natural philosophers, people who excelled at exploring a variety of topics of understanding all kinds of things going on in the world around us. And then we started breaking science apart into disciplines. And so a person could become a geochemist, or they could become an oceanographer or a biologist. And by doing that, it allowed people to specify on very specific topics and get really good at these really singular ideas and push those ideas to the extreme. But it also caused a lot of scientists, not just across the world, but even at single universities, you would have physicists in one building who never walked across the campus to the other building where the biologists were at. They weren't speaking to each other. They weren't even using the same language. They were using different scientific terminologies to explain their fields. And by doing that, we actually lost a lot of potential knowledge. We didn't have a good connection of seeing the larger picture of some of these things. But nowadays, with fields like astrobiology, it's forcing people who are physicists and astronomers and biologists and chemists and philosophers to kind of come back and speak to each other about how all of their various fields play into these big questions. And so astrobiology is kind of improving a lot of science by giving us this larger kind of holistic view of what we need to know to answer the question of whether or not we're alone.
I guess this is what inspired you to be an astrobiologist.
Yeah, when I was very young, I knew I wanted to be involved in science and space exploration and philosophy in some manner. Through college, through going to university, I didn't quite know what I wanted to study, and so I kind of studied a little bit of everything. And honestly, like I loved so much about learning about all these different topics about what life is, whether or not we're alone, what we know about the cosmos. Big questions like what is life, what is intelligence, what is consciousness? Like all of these things kind of drove me towards this realm of astrobiology.
And then you realize that the more you learn, the more questions you have.
Yeah, exactly. It always brings more questions to our minds. The more we learn, the more we place ourselves in the cosmos, the greater we realize that we've learned a lot, but we also have so much more we don't yet know.
Yeah, like with recent discoveries at the bottom of the ocean, right? There is rocks that produce oxygen, and there is no sunlight. How crazy is that?
Yeah, and that's really interesting. It could be a geological battery, allowing not just for production of oxygen, but by having water rock reactions on the seafloor that produce oxygen, or in other systems produce hydrogen that can mix with carbon dioxide and make methane when organisms are present. These are telling us that there could be possibilities for life in ocean worlds that don't have access to a surface environment with sunlight. And we can speak about those then as well. There's places in our own solar system like Europa and Enceladus, moons of other worlds where they have icy crust at the surface and then oceans down below. And this gives us some understanding that there could be a potential for life in those oceans.
Oh yeah, this is my favorite. So if you can talk more about it, or follow your presentation, and maybe what will be the best time. So
Yeah, let me just, I can jump up to that right now. So let's just talk a little bit about what life in our solar system might be possible. There's a few primary candidates for understanding the geological history of planets in our solar system, of moons in our solar system, and some of them present some potential for alien life. And so I mentioned Europa, the image in this bottom right, and Enceladus on the bottom left. These are moons of Jupiter and Saturn, respectively, both of which have subsurface oceans. Enceladus is erupting its water out into space. When that water comes out, it makes the E ring going around Saturn, one of the largest of Saturn's rings. And we now know that there is a global ocean down below its icy crust. There could be hydrothermal activity going on. And so maybe there's also water rock reactions driving chemistry, allowing life to thrive. The same thing happens for Europa, that has a very, very deep, voluminous ocean full of water. If life can start in oceans, and we don't know that for sure yet, but if life can start in oceans and evolve in oceans over time, then maybe Europa and Enceladus are places to look for possible signs of life. But we also have other candidates. So in these images, in the middle, of course, is Mars, the red planet, the fourth rock from the sun. A lot of us have interest in Mars, not just for looking for past signs of possible life or even current life on Mars, but also for sending us there, for sending humans there one day and settling Mars and developing the next world with human biology occurring at its surface, and maybe even terraforming Mars someday to be more Earth-like. There's also worlds like Venus in the top left here. This image, of course, is not actually what Venus looks like with our eyes. If you look at Venus through a telescope, all you see is kind of like a blob of whitish, grayish, invisible light. We can't see through the clouds of Venus, but we can using radar. And so this is an image. It's a composite image. The radar comes from the Messenger spacecraft, looking at the surface of Venus, showing the topography, so changes in the rock. And then it was colorized using the Soviet Union's Venera 13 and 14 landers, the most successful missions to Venus so far, that were able to land on the surface. Venera 13 lasted 127 minutes on the surface of Venus before it broke down. And that's nearly 50 years ago now. And so we really do need to get back to Venus and explore there more. But now there's some idea that there could be possible signs of some biology or something that could support biology in the atmosphere of Venus that's worth looking at. And then finally, in this picture in the top right is the world Titan. Titan is a place that we're not really looking actively for life. Titan is a moon of Saturn. It's an extremely large moon of Saturn. It also has a very thick atmosphere. Its atmosphere goes up very high in altitude on top of the moon. It also has a very interesting chemical cycle, whereas on Earth we have a hydrological cycle where water evaporates and condenses in clouds and rains and precipitates back down and then collects back again in ponds and lakes and goes through this cycle. On Titan, it's a methanological cycle. So there are lakes full of methane and ethane, these hydrocarbons that are then evaporating into the atmosphere, interacting with sunlight, which is creating new chemistry. And then we have this gunk of organic material raining down onto the surface of Titan and going through this whole process again. And so Titan's really intriguing for us to better understand worlds with unique chemistry like this. Now, that said, there could be some possibility for life as we know it on Titan, but maybe in the subsurface. The surface of Titan is extremely cold, and so highly unlikely for any life as we know it to thrive on the surface, but yet maybe down in the bottoms of those lakes or even in subsurface lakes or a subsurface ocean, if it exists, there could be some signs of life as we know it as well. So these are like the five primary targets right now in our solar system beyond Earth when it comes to looking for possible signs of solar system life.
And all of those, except Mars, I think they're pretty extreme environment. I mean, on Mars, we're hoping to find life on the the lake that they've found. Well, we think that it's a lake, underground lake. So, but the other worlds, like Venus, I think it's the last 5 or 10 years, right? They have new theory that their life might exist in the clouds, above the acid rains. Mm-hmm. And with the Titan, for me, it's also fascinating that the land itself is made of iced water. And maybe what do you think about the organisms there? Maybe they're based not on the water as but on methane.
Yeah, it's interesting to wonder, like, could there be some living system that does survive? Now, I will say the temperature on Titan is so low that the very chemical process of metabolism, even if they were metabolizing in methane or ethane instead of water, it's just there's so low energy. It doesn't seem likely for any metabolic processes to happen at the surface. But you never know. I mean, life continues to show us, and the universe continues to show us that we can always learn new things and discover new things about our place in the universe.
Yes, like, with this recent discovery about the rocks in our own ocean, or the results of asteroid Bennu, that they also found some organic materials there, and they were not expecting that at all.
Yeah, we were discovering organics everywhere, honestly. And to be clear, organic itself doesn't mean life. Organic is a term that we use in chemistry to imply any carbon-based molecule other than carbon dioxide and methane. So if it's methane or carbon dioxide, it's called inorganic carbon. But then anything else that uses carbon, from sugars and proteins and DNA to very simple carbon molecules like ethane and propane and butene, those things are all organic compounds as well. And so the hydrocarbons are organic compounds. We have organic compounds that include nitrogen and oxygen, other what we call heteroatoms mixed into the carbon compounds. But there's a lot of carbon chemistry, and it turns out a lot of carbon chemistry just happens in space without life. And so we've now found organic compounds in the interstellar medium, floating around in dust out in space. We found organics in Bennu and other asteroidal materials in comets. We find organics all over the surface of Mars and other worlds. And so organic chemistry is abundant. And so the question then is, like, how do we go from having just organic chemistry to having carbon-based life as we know it? And we really don't know yet what that big step was.
And so, based on current research, what are the most promising locations, in your opinion, or what? I mean, if someone gives you billions of dollars on the mission, where would you go?
I mean, so in our solar system, I know yet. I'm a big fan of Europa because its ocean is very deep and there's a lot of water there. I would love to have a robot that can go down into the ocean and explore there. That would take more than just tens of billions of dollars. Even now, in October, we're going to launch the Europa Clipper mission. It's going to go around Europa and Jupiter together and give us maybe 40 or more flybys of Europa. It'll teach us a lot more about Europa's ocean, its surface, the chemistry around that moon. It might even find plumes of water if they're there, which we don't know for sure yet. But it's not going to land at all. It's just going to orbit around. And currently, even though there have been some proposals for landers for Europa, nothing has been selected nor funded. And even getting down through that ice, Europa's ocean, or its icy crust, is maybe 10 kilometers based on our best estimates right now, maybe even thicker. That's way thicker than any ice we have anywhere on Earth. That's thicker than the Greenland ice sheet. It's much thicker than the Antarctic ice sheet. And so drilling down through that depth of ice is something we have never done before. And so
but they're hoping for the cracks, right? These lines, the brownish lines, there are cracks in the crust, right?
Yeah, those cracks are called linnea. These lines or cracks, they appear to be ridges where the ice has broken. And many people have published great research showing that they actually work like fault lines do here on Earth. So if you look at like a transform fault on Earth, that's a fault where one side of the rock is moving parallel compared to the other side of the rock. If we have like a fence or even a road going across that fault over time, the road or the fence will actually shift. And we can measure the movement of the fault based on that shifting. We actually see the same thing in the ice on Europa. We see the cracking of the crust, and as it moves, we see lines that used to be connected as they slowly move apart. And so it tells us a few things about the surface and how this is all moving around over that huge ocean down below. It doesn't necessarily tell us that the cracks go the whole way down to the ocean, though, which is one thing we're going to explore with Europa Clipper. It's one thing that many of us want to know, like, could there be what we call communication? Now, that's not, talking to each other. It means chemically, is there a chance for materials from the surface to get down into the ocean? And vice versa, could it be that some of the ocean water actually comes up through those cracks and is at the surface for us to look at, we'll know a lot better with Europa Clipper whether or not that's possible.
So let's hope that in our lifetime we will find out what is there in the ocean.
I hope so. I'd love to see a robot go down there. If I had unlimited funding, that's one place I would send a robot. I would send humans to Mars immediately if I had unlimited funding and get humans there to do some research. But even for Venus, I'd love to see us explore Venus with more landers, maybe even like a mechanical rover, or even high altitude balloons.
And for you, there are no ethical considerations when we talk about going to Mars. There's two camps: scientists who are against any humans on Mars because then we won't get the pure data about life or past life on Mars. And scientists like you that you're like, hey, no, we should go there.
Yeah, it's a very good ethical question and one we should consider. And I'll say it goes even wider. There are some people who argue that we shouldn't send humans to space at all, that we should stop all human space exploration due to its costs and the impacts of sending us out there, and the fact that we have so many problems here on Earth that we've created for ourselves that we're not fixing. But then there's others of us who think that human space exploration is not only inevitable, but it's an important part of the future of our civilization. For me, space exploration, especially human space exploration, has united us across the globe. Ever since the earliest object sent into space, the Sputnik, and the first person with Yuri Gagarin sent into space, space has been a way to unite people, to drive us to want to work together to do something better. And so I think space, like solving for space, as my friend Sam Proctor says, solving for space helps us solve for Earth.
Exactly.
And so by going out to Mars with humans, I do think there is a risk that we could contaminate Mars with our own microbes from our bodies and our spacecraft, but that risk is already there. Every single time we send a rover or a lander to Mars, it is not entirely clean. There are some Earth organisms that are going along on those spacecraft. Even if it is a minimal amount, there still is some going there from us. But the thing is, I think we're far more likely to be effective in looking for signs of past or present life on Mars with humans on the ground. Like one geologist who knows what they're doing on the surface of Mars as an astronaut explorer can do way more in one day on an ETA out in the field looking around at the rocks than we can in a decade with a rover. The rovers are great. They have some of the most advanced scientific instruments on them ever, but without having a human there to make those decisions on the spot, it really is difficult. Now, that might change in the coming years as we develop better artificial intelligence systems, better machine learning systems. The rovers have a lot of autonomy on board already. And in the future, our robotic exploration of the solar system, including Mars, might have robots that are almost fully autonomous and getting even closer to being human-like in their exploration. And we may only be a couple of decades away from that.
And now no one talks about ethical considerations when we want to explore Moon. Because everyone thinks it's 100% dead. What do you think about that?
Yeah, I mean, our moon is highly unlikely to have any life as we know it. Even in the subsurface, where we find some frozen ice, for instance, in the southern hemisphere craters, the moon is extremely cold, mostly barren from what we can tell. There's no active geological processes occurring in the modern day. It just seems unlikely to have any kind of life as we know it. Now, I will say for me, one reason to go to the moon with humans and explore, but there's a lot of great reasons. One, we want to go and explore and settle and maybe build great radio astronomy observatories on the far side of the moon and explore possibility for resource use in the future for humanity on the moon. But I also think there's a chance that maybe some of the earliest signs of life from Earth are waiting for us to find them on the moon. So our Earth has tectonic processes. Basically, our Earth's surface is broken apart into a bunch of tectonic plates. These plates around on the surface of the mantle, and sometimes they subduct. So one plate gets run down into the mantle and broken up, and the rock melts and goes back into this process of recycling of all the surface material. We only have a few places on Earth with the oldest rocks, and even then, they're mostly broken apart. It's very hard to tell their history. It's very hard to look for early signs of life on Earth. But maybe in the early history of Earth, after our moon formed, and after a lot of the volcanism occurred, there could have been moments where giant impacts from space blasted ancient rocks off of Earth that landed on the moon. And so maybe some of our Earth meteorites just sitting on the moon right now could have some of the signs of the earliest life on Earth for us to explore.
Yeah, this is fascinating because I'm more into, space resources, especially the moon resources, how to mine it and 3D print habitats and roads and etc. But we should be also very careful when we are starting doing that, because there might be so many precious information, right, and examples of what the life was on Earth. So thank you. We need to have you on board with us, with the space miners.
Yeah, I mean, then there's a lot we can learn in space resources and space mining, especially through developing life to do that for us, like bioleaching of metals and things like that from asteroids, going to the moon with organisms to explore lunar resources. I think in the near future, our biotechnology is going to be a big part of our space resource development. And that might also help us to better understand whether we can find alien life that does that naturally in other places, maybe even in star systems far beyond our own solar system.
Wow, that's so fascinating. Okay, tell me more. I'm so curious now.
Yeah, I mean, I have lots of things we can talk about here. I will say one thing that's really intriguing for me right now. Like, I love our solar system. There's so many cool worlds, but we are learning so much more now about other worlds out there. When I was a kid, we didn't know of any exoplanets at all. It wasn't until 1992 that we had the very first known detection of an exoplanet. And around 95, we started finding a bunch more. Now we know of over 5,000 exoplanets that have been confirmed to exist. These are worlds orbiting other stars. Most of them are very close to our own solar system within the galaxy. And so if we look at the large extent of our galaxy, most of the planets we're finding are in one little corner of our galaxy close to our own solar system. And just based on that small of a number alone, 5,000 plus worlds already detected in that small region, if we extrapolate out, that tells us there could be something like maybe 400 billion or maybe even a trillion planets in our own galaxy. And now we're starting to explore like whether or not there could be exomoons. So moons orbiting around these exoplanets that we could actually look at and detect. There's a group right now led by David Kipping who have time on the James Webb Space Telescope who are looking just for these exomoons. We're using things like the James Webb Space Telescope and ground-based observatories and the future upcoming observatories like the Roman telescope and then the upcoming Habitable Worlds Observatory are going to be looking at these exoplanets, looking at their atmospheres, trying to see if there's any signs of life, of a biosphere. I'm also really intrigued by the concept of technosignatures. So in astrobiology, we have this realm of research into biosignatures. A biosignature is a sign of life. It's a chemical system, a structure, a pattern, something that is indicative of biological processes that can be created by life and should not exist without the presence of life. And so we're looking at places like Mars and Venus and some of these exoplanets for biosignatures. But within that research, within looking for signs of life, there's another realm of technosignature research, which is looking for signs of technological activity, looking for intelligence out there through messages via radio waves or from visible light and other forms of electromagnetic radiation. There's also looking for actual artifacts. It might sound like science fiction and far-fetched, but there are some of us who wonder, like, are there any remnant alien artifacts in our own solar system for us to find? We humans back in the 1970s, we launched the most distant piece of humanity right now in the Voyager 1 spacecraft. It's still traveling in our own solar system, even though it's in interstellar space, and it will travel for many thousands of years before it gets to close to any other star system. But still, we have to wonder, like, were there alien civilizations long ago who also launched things out into space? Or are there any current alien civilizations that have technologies to launch things into space and get to places faster? And could any of that material, technological artifacts, could it have landed on places in our own solar system? Could it travel through our solar system? We don't know.
Like recent one, I think everyone had more hopes on Oumuamua, if I say it correctly. Can you tell me more about that?
Yeah, Oumuamua was the very first object detected that we could say for sure came from interstellar space and entered into our solar system. And that's based on the trajectory it was coming in. So with comets, we have short period comets that come in from the Kuiper belt around the orbits of like Neptune and Pluto. They come in, in like 50 years or 200 years and go around our sun and go out. We have other comets that are long period comets that go out to what's called the Oort cloud. It's a predicted region of space that's spherical around our solar system, where we see these long period comets coming in and doing these long ellipses that take 10,000 or 20,000 or more years to come in and go around the sun and go back out to this region of space. But with Oumuamua, we found a hyperbolic trajectory where it was screaming inward and flying back out really fast. It's still traveling in our own solar system. There was even a proposal to go try to catch up to it with a spacecraft, which we actually could still do if we did it right now. But with this object, we were able to tell right away that it was interstellar in nature. We only got a little bit of data on it, though, to actually say what it was. But even based on those data, most scientists are of the consensus, most planetary scientists and astronomers are of the consensus that it was something in between like an asteroid and a comet. So it was fairly rocky, but also had a bunch of ice. It appears like kind of like long, elongated structure, the way that it came in and back out again. However, there was one researcher, Avi Loeb, at Harvard University, who proposed that maybe this was an artifact of alien intelligence, that maybe it was a piece of a solar sail or a spacecraft. Not many people agree with that based on the data we have, but we are also very limited in the data that we collected. And if anything, Avi's done a great job not only of talking about Oumuamua, but we now have other interstellar objects. So we've actually measured a few of them now that have come into our solar system and gone back out. And it tells us that over the history of our solar system, over the last 4.56 billion years, there's probably been a good bit of material coming in and out of our solar system from the rest of the galaxy. That probably happens regularly. And we just now have the technology with better telescopes to actually see this stuff happening and monitor it. It also tells us that maybe we should be better prepared for the next interstellar object, which again, we don't know if Oumuamua was potentially alien in nature. I don't think so. I think many of us hold the consensus that even though we are lacking data, it most likely was not an artifact of alien life. That said, maybe we should be better prepared with our telescopes, with our technologies, for an object that could come into our solar system and could be an alien artifact. And I have some colleagues who are making that argument right now, that we should be ready for this just in case it does happen. And it is possible. It could happen. We've already launched a bunch of things into space that are traveling out into the universe, and we'll likely do it again.
Yeah, and I wish we could have the very advanced spaceships that we could actually go there, fly by, and see it with our own eyes. But well, I think it's. What do you think? Will it happen in 30 years, 40 years?
We don't know. Right now, our space propulsion technologies are still fairly limited. For the most part, we still rely on chemical rockets, chemical propulsion. There have been ideas of using nuclear fission rockets, and then now we're working on developing solar sail technology, ion engines, and things like that. But getting off the Earth and into space is still very much chemical propulsion based. But who knows what the future holds? Maybe, with science, you never know what the future will be. Before Einstein came around, people just thought, that Newton's laws of physics were the end. That was it. We discovered everything we needed to know. And then we came around with Einstein and relativity, and we realized there's more to the cosmos than we know. Maybe when it comes to things like nuclear fusion, it might be tomorrow or in a decade that we finally figure out fusion to the point where we can harness the power of nuclear fusion, harness the power that drives stars. That might change everything overnight, not only for powering our planet and our technologies, it might also help us to get off the planet faster and get out into the cosmos much faster. There's also other ideas about ways to develop technologies to get closer to the speed of light. One really cool idea is using laser pulsed solar sail technology. So currently there's an idea of using a giant fleet of very small, like centimeter-sized spacecraft with large solar sails around them to use giant lasers from the Earth to pulse and hit these solar sails and push them maybe 1/5 of the speed of light so they could get out to a place like our next closest star beyond our solar system in maybe 20 years or less. Those ideas are very cool, but we're just not there yet.
I think there was a project, or he still exists, by Yuri Milner. Yeah.
Yeah, that's what I'm
So
talking about. Yeah, it's the Breakthrough Initiative.
yeah,
And so within the initiative, they have a few different things they're doing, and one of those is Breakthrough Starshot, that was funded by Yuri Milner. And that's the idea of using these pulsed solar sail, of a fleet of very small solar sail spacecraft with very low mass to get them up to close to the speed of light to get out to Proxima Centauri as fast as possible. But the future might be radically different than what we imagine it being. Maybe in 10 years or 20 years or 50 years, we humans will have changed drastically through our technologies, through our understanding of ourselves, through politics and economics and all the things that we do. And maybe we are on the next cusp of exploration of our galaxy and of our universe.
I really hope so. And you were talking about that we are looking for signs of life or of technology, and so far we didn't hear any of them, right? Or didn't saw it. And we have a great comment on our Telegram channel related to it. I'll just read it out loud. Of course, I believe that we are not alone in this universe and in this galaxy. It's ridiculous to think that the humans are the only rational species. We just don't know about their intelligent species. I guess we are not the most advanced civilization in the galaxy, so other species might be much more advanced and follow the prime directive, don't affect the low advanced society. That's why we still didn't have any communication.
Yeah. There's a famous quote from Arthur C. Clarke. Sometimes I think we're alone in the universe, and sometimes I think we're not. In either case, the idea is quite staggering. Now, I will say, currently, we have no evidence that alien life has ever existed. We've had like these little glimmers and hints. We have astrobiology helping us to figure out what signs to look for. We've had a few possible jump starts where we thought we found something, but then had to kind of reel back a little bit and really explore it scientifically. So far, we have not found alien life. And so based on logic and, in the realm of philosophy, when we start building like logical models of what we know and don't know, based on our current knowledge, we have to admit that we could be alone. That is one possibility based on all of our knowledge right now. If we find an alien message tomorrow, or we find, certainly like a microbe on Europa, or, a whale in Europa's ocean that's like an alien whale, or find some life on Mars, that would change everything. But as of now, we have to admit we could be alone. But in this field of astrobiology, the more that we're learning about other worlds out there, possible environments, what life on Earth can do, and what other life might be able to do, it feels like that potential for us being alone is getting smaller and smaller and smaller. It's a diminishing possibility. At least it feels that way in a very human sense. It feels like if there is something else out there, we might be on the cusp of finding it. But as this commentator has suggested, there are some reasons to explain why we haven't found aliens yet. Amongst those possible reasons is that space is extremely vast, and maybe no one has figured out how to get up close to the speed of light and send biological entities across the galaxy. Maybe we are amongst some of the very first worlds to develop intellectual beings who want to know if others are out there, but none of us have had enough time to send our messages or send our spacecraft yet. That's very possible. Maybe we are the very first to develop intellectual society and start sending messages out. That's also possible. But what your commentator shared here, I really appreciate, is the idea of the prime directive. And it's one of my favorite answers to what's called Fermi's question. So Enrico Fermi, back in the 1950s, went out to lunch one day with his fellow physicists, and they were talking about traveling at the speed of light or even faster than the speed of light, whether it was ever possible. And Enrico Fermi came up with this question that he asked everyone at lunch, and they all went home and noted it in their notebooks. And now we think of it as sometimes called the Fermi paradox, even though it's not actually a paradox. It's just a question that has many possible answers. But the question is, where are they? Like if faster than light travel is possible, or even close to the speed of light is possible, where are the aliens? And so one of my favorite answers is basically this. It's the prime directive. It's also called the zoo hypothesis. It's the possibility that maybe they are out there. Maybe they've been watching us. Maybe they're very well aware of us, but they're keeping us basically like in a glass menagerie. They're watching us from afar and seeing what all the life here is doing in our little zoo, but they haven't yet decided to interact. Maybe because we're too primitive and too basic. Maybe because we keep harming ourselves through warfare and things like that. But it's also possible that maybe they're waiting for us to show them something. Like maybe they're waiting for us to show them that we have technology that allows us to join the Galactic Federation. Maybe we have to develop fusion technology or faster than light travel, which is what Star Trek proposed. Maybe they're waiting for us to show them some change in us consciously. Maybe there's some next level of evolution that biological beings can come to that allows us to join up with the rest of the aliens out there. Or, and this one is kind of terrifying for some people, there is the potential that maybe they're waiting to see if and when we turn into robots. So right now, we're developing artificial intelligence faster than ever. We have these large language models and generative AI. Our machine learning programming is getting better and better. And a lot of us wonder, like, are we going to replace ourselves with artificial life? We're building humanoid robots. We're building many other kinds of robots. And with artificial intelligence and maybe even artificial general intelligence in the future, which is a proposal that maybe one day our AI will become sufficiently advanced that it is capable of reasoning, not just intellectual reasoning, but also creative, imaginary reasoning at the level or better than a human. And some of us think this is very possible, even in the coming decade or two, maybe slightly more. If that's the case, maybe most other alien technology out there is actually AI, or what we call post-biological. Maybe most alien biospheres go through the same thing we're going through, where they come to this cusp of developing AI and developing their own robotic machine, biospheres, and then that's what becomes the technological civilization that communicates. And so one possible part of the zoo hypothesis is that we're being watched by a bunch of machines who are waiting for us to become machines too, to join them.
Wow, that's really interesting. I actually never thought about it in this way. And comes to my mind Terminator and other movies.
Yeah, I mean, there's a lot of uncertainty. I mean, certainly in science fiction, we've often presented this possibility of machines taking over in more of a negative light. So we see Skynet in the Terminator series. Most people know of The Matrix, which is a great way of telling the story of Plato of the cave and really exploring a lot of religious and philosophical concepts in what it means to be human within this realm of the Matrix and the machines and having a war with humanity. There's a lot of newer films and especially video games where they've really explored this idea a lot. We don't see as many, though, presenting it in a very beautiful light, which is quite possible. I will say one film that I thought did an interest of presenting what this could be at the very beginning was Transcendence with Johnny Depp. They did a great job in that film of exploring at the very end. I won't give too much away, but they kind of explored what could be possible for our biosphere to transcend to that next level and what that very first jump getting there might be like. It might be terrifying for people at first because they're just not on the level of understanding what it's actually going to be. And it also sounds kind of scary because it does imply that we are gone, that we humans get replaced by whatever comes next.
Yes. Wow. I hope our listeners have questions. So far, I didn't see any, but let's move on and wait for some questions from them. Yeah.
Yeah, I can also chat about a few more things if people are out there watching. One of my favorite things to talk about is the Drake equation. This was famously created by the astronomer Frank Drake, who passed away some years ago now. Frank Drake in 1960, he got together a group of scientists and scholars to ask the question, what do we need to know right now to find out if there are other technological civilizations out there who are trying to communicate with us, with whom we might have a dialogue? And he put together this equation kind of as like, it was basically the blueprint for the meeting. Like, here are the things we have to talk about to figure out what we know and what we don't know to find possible signs of life out there, of intellectual civilization. And so very quickly, I know this might look like for some people kind of confusing of an equation. It starts with this big capital N. The N is the final output, the number of civilizations that have technology with which they can communicate right now in the galaxy with us. And what it starts with is R star, or this R with an asterisk beside it. R star is the rate of formation of stars in our galaxy per unit of time. If we do it per year, the current estimate is like 2 or 3 stars per year on average are forming We can do it per millennium, per billion years. It doesn't actually matter that much. It all kind of works out the same. We get some number of starting stars. And then after that certain number of starting stars, whether it's 2 or 3, or it's 2 billion or 2 trillion, whatever that number is, after that, we start breaking down that number, looking for possible biospheres. So we have the F with the sub P. How many stars have planets? Well, right now, based on our current knowledge, we actually think every single star usually has at least one planet, if not many. So that's one. But of those planets, how many are Earth-like? This is one place there. In 1960, they thought that an alien world to have a biosphere has to be Earth-like. Many of us now think that might not be the case. Maybe Venus or Mars, which are fairly Earth-like, but not quite. Maybe they had life. But also like Europa or Enceladus might have life. And so maybe there's actually a large fraction of possible worlds that could have life. But of those, now we have the F sub L, F sub I, F sub C part of this equation. So basically, we start breaking this down by smaller and smaller fractions. The F sub L is the fraction of these worlds that have life. We have no idea what that number is, or fraction could be. Of the worlds that could have life, how many develop it? To our best knowledge, so far, it's only one. But maybe there's many worlds. Maybe if a world is sufficiently Earth-like or has a sufficient environment like Europa or Enceladus, maybe it makes life. But then things get even more wild with the F sub I and F sub C. These are the fraction of worlds that have intelligence and the fraction that develop communication so they can actually communicate with us. We don't know what these are. We don't actually understand what intelligence even is yet. Some humans think that only humans are intelligent on our planet. But as many of us can tell you, that's obviously not the case. I look at my dogs, they're super intelligent. We look at creatures like whales and dolphins and crows and ravens. We see lots of signs of intelligence all across the planet, but it's very different kinds of intelligence. But my favorite part of the whole equation here, so once you get down to some fraction of worlds that can develop communication and communicate with us, they added in the last factor, the big capital L there. The L factor is the lifetime of civilizations. How long could a civilization last? Could we be on the cusp of destroying ourselves or replacing ourselves with robots? Again, these are big questions that astrobiology forces us to ask ourselves.
Yes, and we have some questions. Okay. How are advancements in technology such as AI and machine learning influencing the field of astrobiology and the search for extraterrestrial life?
Ooh. I'll say that there's two sides of that. The one side I already mentioned is the consideration of aliens developing AI and whether or not that means that most life out there is post-biological or not. That's a slightly separate side of how we're using the technology right now ourselves. So on the other side is how are we using machine learning and artificial intelligence in astrobiology? And there's a lot of ways. I already mentioned earlier that our rovers on Mars right now, Curiosity and Perseverance on Mars right now, they have some level of autonomy on board. That means the computational systems on board the rovers can make some decisions without input from humans, especially for driving. And so for rovers, it's a very slow process to drive a rover around the surface of Mars. And so we realized if we can teach the rover some things to look for, we can actually let it drive itself a little bit. And so by letting it drive itself, it knows that if it finds a possible obstacle or it might flip over or something, it stops. And then it communicates back with us. It tells us what is around the environment, and then we can help it make better decisions. But that level of autonomy is getting better and better. Future spacecraft, especially robotic spacecraft going to other worlds, will most likely have better and better autonomy on board so that the robot can make decisions for itself of where to land, how to drive, how to fly through an atmosphere, and all kinds of things. But we're also using machine learning and AI systems to analyze data. And so, we're getting better and better at building instruments that can collect extremely large data sets. So rather than like looking at one rock and zapping it with a laser and taking one single data point in one wavelength, we can scan across a bunch of wavelengths with the laser, and we can also collect it many, many times over time. And so maybe we have, a million data points. In the near future, maybe we'll have 1 billion data points on board our spacecraft. And so we can build in machine learning and artificial intelligence systems that analyze those data first before sending data back to Earth, which can save us a lot of time. So basically it processes all the data and then it sends it back and it says, here's all the interesting things I found. Take a look. We would still have the raw data if we wanted it, but then we also have a chance to explore more through AI systems, machine learning systems.
Yes, this will be amazing. And okay, so I have another question. Dr. Lau, what do you think about the Expanse book series and TV show?
Love them both. So The Expanse, if you haven't read or watched, for those who are watching, The Expanse is a very interesting series of novels with a TV show based on them, written by two authors together who joined forces to be known eponymously or through a pen name of James S.A. Corey. In the books, it presents a future not too far ahead of us where humans have settled on Mars, and they settled in the asteroid belt beyond Mars, and they started breaking apart into different kinds of human civilization. The stories very much center on the human stories, what's happening in the near future, and they very much present a tribalistic future for humanity, where we still are at odds with each other over a variety of things through our socioeconomic policies and all these kinds of things. And so you have war going on between Earth and Mars and the belt and Earth. But then centered around that story is an alien molecule that changes the game for the solar system. It drives a lot of the action forward. And later, by the last few novels in the series, they kind of get a bit bigger in scale and really start exploring the galaxy and exploring what this alien molecule could do for humanity. And so there's two big things going on in The Expanse. One is the larger framing of the alien molecule driving the exponential evolution of our civilization for humanity. And the other side of the story is very much what a future could be for us. I will say, even though I love the stories and they're fun telling, I hope that's not our future.
Yes.
Because in that future, it presents humanity as still warring and still constantly at odds. And it presents us as a species who's still not figured out how to get over our tribalism. Even after this proto-molecule, this alien molecule drives us forward, we still have these problems. And so I'm hoping our future is going to be a bit better than that for all of us. Oop, did I lose a connection here?
Okay. Yeah, I think I was frozen or something.
Oh,
Sorry.
okay. No worries.
Yeah. All right. So we have 1 minute left, and we have last question. What ethical considerations should we keep in mind when exploring other planets and potentially discovering extraterrestrial life?
Yeah, that's a huge question.
Yeah.
And one that I can't quite answer easily in 1 minute, but I will say there's a lot of things to consider when it comes to, if we find alien life, should we take it and explore it and learn more about it? Should we leave it alone and let it evolve on its own? These are big questions people have been asking for some time. Also, when exploring other planets, should we take risks that might hurt life here on Earth? So some people are opposed to bringing samples back to Earth from Mars and other worlds because they're afraid that there could be back contamination, where we actually bring some alien virus or alien bacterium or pathogen back to Earth that could actually cause some damage to us, or it could radically alter our biosphere in some unknown way. So a lot of really interesting things to explore. If you're interested in that, I highly recommend checking out The Philosophy of Science and The Philosophy of Astrobiology, because there are big moral philosophy questions we should ask about whether or not we should go out in the cosmos and how we ought to explore space.
Thank you. It was such an amazing conversation with you, and I got so much new knowledge, and I think our listeners too. Please join us on August 19 at 8 p.m. Moscow time, where you will be able to ask Dr. Lau directly on a Zoom session. And also, Dr. Lau has his own YouTube channel, so you can listen to more of his lectures. And if you really want to, get more detail into the astrobiology, he's the best person for that. So thank you so much, Graham. It was a pleasure.
Yeah, thank you so much for having me. I appreciate it.
See you in 2 weeks.